Now we're going to define what all these movements mean. We've been talking about flexion, extension, rotation. What do they mean? So flexion simply means when there's a decrease in the size of the angle at a joint. Meanwhile, extension is just the opposite, when there's an increase in the size of the angle at a joint. Let's use these examples right here to illustrate flexion and extension. So here's a knee, and let's say you were to kick this ball right here. You move your foot forward, the angle at the knee joint will get bigger. If you move your foot from here to here, the angle at the knee joint will get bigger, right? So that is extension. However, if you were to bring your foot backwards, maybe you're doing a heel flick or something, then the angle between the lower leg and the upper leg will get smaller. So that would be flexion. Now, same thing at the elbow. Let's say you were lifting a weight. Let's say this is a weight here. This is a dumbbell. If you were lifting this dumbbell up, that would be flexion, because this angle at the elbow will get smaller when you move up. Now the opposite, if you were bringing this dumbbell back down, then that would be extension, because this angle at the elbow would get bigger. Rotation is when a bone moves around a fixed axis at a joint. Circumduction, we've also spoken about, is when there's a movement in the shape of a cone at a joint. Adduction is when the limb moves towards the midline of the body. Meanwhile, abduction is when a limb moves away from the midline of the body. Now, a little trick to remember which is when you see add, just remember you're adding that limb towards the midline of the body. Meanwhile, when you see abduct, it's almost like someone is getting kidnapped or abducted. They're being taken away, so your limbs are being taken away from the midline of the body. Okay, so these are two examples of abduction and adduction. For abduction, let's say this is LeBron James shooting a basketball into the basket like this. He obviously has to lift his arms away from the midline of the body to get them above his head. So that is abduction. Now, on the other hand, we have a javelin throw by some athlete. I don't really watch javelin, but let's say they're about to throw a javelin. They are now moving their arm towards the midline of the body to throw that javelin. So that would be adduction, because they are adding that limb towards the midline of the body. We have plantar flexion and dorsiflexion. These are both movements that happen at the ankle. So plantar flexion is a downwards movement of the foot at the ankle. Meanwhile, dorsiflexion is the opposite. It's the upwards movement of the foot at the ankle. So think of plantar flexion like when you point your toes downwards, and dorsiflexion is when you bring your toes upwards towards your shin. So just to show what's really happening at the ankle, we have the upper leg here, the lower leg here, and the foot here. Okay, so if you were to move this ankle, move this foot downwards, let's say during the upward phase of a calf raise, you're obviously pushing down into the ground to bring your body up. That would be plantar flexion, because you're pointing your toes downwards away from the shin. Now, if you were to bring that toe or bring that foot upwards towards the shin, let's say towards the downward phase of a calf raise, when you're lowering your body down and the angle in between your shin and your foot is getting smaller, then that would be dorsiflexion. So in the body, you have hundreds and hundreds of muscles. These muscles have different functions, and we can split these different muscles into three different muscle types. We have skeletal muscle or voluntary muscle. We also have smooth muscle or involuntary muscle, and we have cardiac muscle. So skeletal muscles are the muscles that connect to your bones through tendons, and these are just things like your biceps, triceps, your quads, your hamstring. And the key thing about skeletal muscles is that we have voluntary control over them, so you can consciously decide when you want to contract or relax these muscles. Next, we have smooth or involuntary muscles. Involuntary muscles are those that we don't have conscious control over. These muscles are usually found on the lining of blood vessels, or maybe even on the lining of organs like your stomach, and they contract very slowly and very rhythmically. Thirdly, we have cardiac muscle. Cardiac muscles are found in the heart. So the muscles that are currently beating your heart right now, are called cardiac muscles. And just like involuntary muscle, we have no control over cardiac muscle. That's why your heart continuously beats throughout your whole life, even when you're sleeping. Now, these are the different muscles that you need to know for your exam. We're going to start with the deltoid, which is found at the shoulder. This is responsible for abduction of the upper arm at the shoulder. Next, we have the biceps and triceps. Biceps are responsible for flexion of the arm at the elbow. Meanwhile, triceps are responsible for extension of the arm at the elbow. Next, we have the pectoralis major. The pectoralis major is responsible for adduction of the arm at the shoulder. Your latissimus dorsi is responsible for adduction of the upper arm at the shoulder and also rotation of the upper arm. Your external obliques are responsible for flexing your trunk or twisting of the trunk. Your hip flexors are responsible for hip flexion. Your gluteus maximus is responsible for hip extension. Your quadriceps are responsible for knee extension. Your hamstrings are responsible for knee flexion. Your gastrocnemius is responsible for plantar flexion. And your tibialis anterior is responsible for dorsiflexion. Now, most of the time your muscle doesn't just work on its own. It usually works in pairs, or maybe even 3 or 4 at once. So we have antagonistic muscle pairs, which are when two different muscles work together to allow a movement to happen. In an antagonistic muscle pair, we have the agonist, which is the muscle that contracts, and we have the antagonist, which is the muscle that relaxes. So this is our first antagonistic muscle pair, and this is between the tibialis anterior and the gastrocnemius. So TA stands for tibialis anterior, G stands for gastrocnemius. During dorsiflexion, which is when your foot comes upwards, the tibialis anterior will contract. Therefore, it's the agonist, because the muscle that contracts is the agonist. Meanwhile, the gastrocnemius will relax to allow this movement to happen. So the gastrocnemius would be the antagonist. Now, on the other hand, during plantar flexion, which is when your foot moves downwards away from the shin, the tibialis anterior would now be the antagonist, because it's going to be relaxing instead. And your gastrocnemius would now be the agonist, because your gastrocnemius will be contracting to allow plantar flexion to happen. Now, our second antagonistic muscle pair is between our quadriceps, this muscle right here, and our hamstrings, this muscle right here. So let's start with flexion. During flexion, which is when the angle at your knee gets smaller, your quadriceps are going to relax. So they're going to be your what? Antagonist, because the antagonist relaxes to allow the movement to happen. Meanwhile, your hamstrings would contract to allow this movement to happen. So your hamstrings would be the agonist. During extension, for example, kicking a ball or whatever movement requires you to move your leg forward, the angle at the knee is going to get bigger and the quadriceps are going to contract. So your quadriceps will be your agonist. Meanwhile, on the other hand, your hamstrings are going to relax. So your hamstrings are going to be your antagonist. Okay, so this is our third antagonistic muscle pair at the arm. So right here, we have your biceps. Right here, we have your triceps. During extension of the arm at the elbow, the arm moves downwards. The angle at the elbow gets bigger because it's extension, and your biceps would relax. And so, by relaxing, they are going to be the antagonist. Meanwhile, your triceps are going to be the ones contracting to pull this lower arm backwards, and so they're going to be your agonist because they're the ones contracting. Now, on the other hand, during flexion, where this arm moves upwards, your biceps are going to be contracting, so they're going to be the agonist. Meanwhile, your triceps are going to be relaxing, so they're going to be the antagonist to allow this flexion movement to occur. This is your upper leg, your lower leg, your foot, and let's say during flexion, let's say at the beginning of a race, you're driving your knee upwards to get that acceleration going. Your knee or your upper leg is obviously going to move forwards, and this is going to be called hip flexion. Your hip flexors are going to be the agonists during hip flexion because they're contracting. So your hip flexors during hip flexion would be the agonist. Meanwhile, your gluteus maximus is going to be relaxing, so they're going to be the antagonist. On the other hand, let's say that sprinter at the beginning of the race is now pushing their leg back downwards, pushing their legs back towards the track. Their gluteus maximus, which is this muscle right here, is going to be contracting. So their gluteus maximus now would be the agonist. Meanwhile, their hip flexors are going to be relaxing to allow this hip extension movement to happen. So the hip flexors in this case are going to be the antagonist. Okay, now last thing we're going to look at today is muscle fiber types. Now keep in mind, muscle fiber types is different from just saying muscle types. We looked at muscle types before, the smooth, skeletal and cardiac muscle. These are different. These are muscle fiber types, not just muscle types. So we have 3 different muscle fiber types, 3 different functions, 3 different structures. We're going to start with slow twitch. Your slow twitch muscle fibers are best suited towards low intensity, long duration exercise. This is because they have low force production, they have a high tolerance to fatigue, and they also have slow speeds of contraction. Now your fast twitch muscle fiber types, or your type 2A muscle fiber types, are best suited towards high intensity exercise and moderate duration exercise. This is because they have high force outputs, they have medium levels of endurance, and they have fast speeds of contraction. Now lastly, on the more extreme end here, you have your fast twitch type 2X muscle fibers. These are best suited towards short duration and very high intensity exercise. This is because they have very high force outputs, they have very fast speeds of contraction, but they have very low tolerance to fatigue, which means they are definitely not suited to endurance activities.